Hello everyone, welcome to lesson 9-6, Permutations. For this lesson, we're going to continue to address the question, how can you predict the outcome of future events? And the new word is permutation. Okay, let's take a look at the real world event, where we have this young boy over here thinking about the chores he has to do. I can see right here, just based on the picture, that he has homework, looks like he has swimming, and mowing the lawn to do. So, what does that have to do with our lesson today? Well, permutation has to do with identifying all the possible outcomes in an orderly fashion, so in sequence, in how many different ways these list of events can be done if you were to put them sequentially. So, for example, scheduling. Colt is planning his Saturday. He wants to mow the grass, go swimming, and do his homework. How many different ways are there to arrange what he wants to do? So when we find all the different ways, we're actually doing a permutation, all the different outcomes. Fill in the blanks of the organized list below to find all the possible arrangements of the activities. So let's see. We have, for example, mowing the lawn. You could do mowing the lawn first. He could do swimming next and homework third. He could do mowing the lawn first, homework next, and then what would be here? Swimming, right? That's the only one, the other one that's left. And now if we wanted to put swimming first, then we put mowing and homework and so on. So make sure that for every single line we cover every event. So now here I would have swimming, homework, and then mowing would be the next one. Over here we have homework, it could be swimming and mowing, and then homework, mowing, and swimming. So you can see that those are all the different sequences that we could have for these three events. So that would be 1, 2, 3, 4, 5, 6. 6 of them. Okay? Essentially, what it turns out is that you have 3 different events. After choosing from those 3, one from those 3, then you only have 2. And then after you choose one from those 2, then you only have 1. And really, what it turns out to be is 3 times 2 times 1 is 6. And you can see that there's 6 different ways to organize those 3 events. Question 1 addresses this method. How many choices does Colt have for his first activity? Well, he has first 3 choices, right? He could either mow, he could swim, or he could do his homework. Question 2. On the first activity, once the first activity is selected, how many choices does Colt have in the second activity? Well, let's say he chooses mowing as the first activity. Now he only has 2 choices. Now, after that, he can either choose to swim or to do his homework, right? He only has 2 more to choose from. And then once the first and second activities are selected, how many choices does Colt have for the third one? He really only has 1, right? Only 1 choice because there's only 1 activity left to do. So just as mentioned earlier, you first have 3 choices to choose from. As you see right here, 3 choices to choose from. You choose 1, then you only have 2 choices to choose from. And then once you choose one of those 2, there's really only 1 choice to choose from. And when you multiply them all together, you will get 6. And there you go. You can use the fundamental counting principle to identify how many outcomes you can have. So here's the main point of the lesson. A permutation is an arrangement or listing of objects in which order is important. See, for the example, we have mowing, swimming, and homework. We have 3 to choose from in the beginning. Once you've chosen 1, then you only have 2 other choices. Once you choose from those 2, then you only have 1 choice left. Okay? So you start with these 3 choices, and then they work yourself down to 2 choices, and then only 1 choice. And how many choices do you have at the end left? Well, we just did that example, correct? You can use the fundamental counting principle to find the number of permutations. Okay, so here we have another example where we're given 3 initial choices, right? And then once you choose one of those choices, you're only left out to 2. And then once you've chosen from those 2, you only have 1 left, right? Let's read it. Julia is scheduling her first 3 classes Her choices are math, science, and language arts. Use the fundamental counting principle to find the number of different ways Julia can schedule her first 3 classes. So she has 3 classes in here to choose from: math, science, and language. Let's say she chooses math. Now she only has language and science to choose from. Let's say she chooses science. Now she only has language to choose from, right? When you actually use the fundamental counting principle, you can just simply multiply all 3 of these and you will get 6. There are 6 different ways to organize or to create sequences with these 3 courses. So there are 6 possible arrangements or permutations of 3 classes. So there are 6, instead of saying 6 different arrangements or 6 different ways to align these, you can say 6 different permutations. Example 2. An ice cream shop has 31 flavors. Carlos wants to buy a 3-scoop cone with 3 different flavors. Okay, 31 flavors, but he wants 3 different flavors. How many cones could he buy if the order of the flavor is important? So there are 31 choices for the first scoop, right? 30 choices for the second scoop, and 29 choices for the third scoop. Once you use one of the choices, there's no longer there. So then you only have 30 choices left, and then you only have 29 choices left. Using the fundamental counting principle, 31 times 30 times 29 equals 26,970. Carlos could buy 26,970 different cones. Yes, different options with the flavorings. Okay, let's see if we can do this on our own then. In how many ways can the starting 6 players of a volleyball team stand in a row for a picture? Okay, so for the first one we have 6 players to choose from, right? So we would write down the 6 players. And then once we choose where one of those players is going to go to, we only have 5 players to choose from, right? Then we take that one player and we place him somewhere, and now I only have 4 players to choose from. Again, we take one of those players and we place him for the picture, and now we only have 3 players to choose from, and then we choose another one, and so on, and then finally the last player, correct? So now using the fundamental counting principle, we would multiply 6 times 5 times 4 times 3 times 2 times 1, right? So 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360, and 360 times 2 is 720. 720 times 1 is 720. So that would give us 720 different ways to arrange the players, or 720 permutations. Question B. In a race with 7 runners, in how many ways can the runners end up in first, second, and third place? So we have 7 runners, okay? In how many places can the runners end up in first, second, and third place? So we only really need to place these 7 runners in 3 different places, right? So we're looking for how many permutations there are. So really what we need to do is we start with 7 runners. I choose from those 7 runners. Then I only have to choose from 6 runners, and then I choose from 5 runners. And the only reason I'm going down to 5 runners is because I only need 3 different runners to fill in these places, right? 5, that's all I need. So I would say 7 times 6 times 5. So we have 7 times 6 is 42, times 5 is 210. So you can say that there are 210 permutations for finishing in first, second, or third place. So let's take a look at an example of how this permutation can work. Here we have the symbol probability is 31 to 3. Okay, 31 different at 3 different times. Okay, 31 flavors, I believe, was the option that we had. 31 ice cream flavors, and he wanted 3. So the way it would work is the symbol represents the number of permutations of 31 taken 3 at a time. Okay, so 31, start with 31, and then we're taking 3 at a time. So we will take the first one, then we take the second one, and we take the the last one. So we use these three as factors. So we first start with 31 flavors. Then after we choose one, we only have 30 flavors. And then after we choose one of those, we have 29 flavors. So we find the product of these three factors. And here we have an example 3, okay, where we have to find the permutation of 8 different choices, but we only need 3, right? So we take the 8, we make the decision for the 8, then we take the 7, because we only have 7 choices, and then the 6, or 336 once you multiply the 3 numbers. Okay, let's take a look at these 3. For example, we have 12 to choose from, and we only need 2 of them, right? So at 12, that's my first choice, and then after I've chosen that, I only have 11 to choose from, so when we multiply these two together, we get 132 permutations for either finishing, let's say, in first or second, or for choosing strawberry and chocolate out of 12 different flavors, okay? The combination, sorry. Now, here we have, for example, on D, we have 4 different choices, okay, and we want to know the top 4. So what do? We go ahead and we just take from 4. After I have 4, I only have 3 choices, and then I have another choice, so 2, and then finally 1. Okay, so we need all 4 of them. 4 times 3 is 12, 12 times 2 is 24, and 24 times 1 is 24. So we have 24 different permutations. And then finally, question E. We start with 10, okay, and we need to go up to 5 of them. We need to choose 5 out of the 10 possible choices to range. So then we go to 9, 8, 7, 6. There we go. Now we have 5. So we go ahead and we find the product of all these factors, and we get 30,240 permutations. Okay, permutations can be used when finding probabilities of real-world situations. So what do we mean by that? Let's take a look at this situation here. Ashley's MP3 player has a setting that allows the songs to play in a random order. She has a playlist that contains 10 songs. So these 10 songs can play at a random order, right? What is the probability that the MP3 player will randomly play the first 3 songs in order? The first 3 songs that she added, it's actually going to play them in order and not at random. Find the first permutation. First find the permutation of 10 things taken 3 at a time. Okay, so let's see. If we understand that it's a 10 and we only want 3. So what we're going to do is we're going to work our way down. So we choose 1, and then we choose 1 from the next pile, and then 1 from the next pile. And when we do that, we get 720. So 10 choices from the first song, and then when you want to play the second choice, you only have 9 choices. And for the third song, you have 8 choices. So there are 720 different ways to play the first 3 songs. Since you want the first 3 songs in order, there's only 1 out of 720 ways to do it, correct? So the probability that the first 3 songs will play in the order like alphabetical order, for example, will be 1 out of 720. Example 5. A swimming event features 8 swimmers. 1, 2, 3, 4, 5, 6, 7, 8. If each swimmer has an equally likely chance of finishing in the top 2, what is the probability that Yumi will be in first place and Paquita will be in second place? First find the permutation of 8 things taking 2 at a time, or P, okay, for 8 things taking 2 at a time. So here we have, first we have 7. Our first choice is out of 8, right? And then our second choice will be out of 7 because we choose 1. So really we only have 2. So that would be 56. 56 different. There are 56 possible arrangements, okay, or permutations of the 2 places. Since there is only one way of having Yumi come in first and Paquita in second, the probability of this event is 1 out of 56. Okay, so now let's try the question. Two different letters are randomly selected from the letters in the word math. So there are 4 letters, correct? And we're choosing 2 random letters. What is the probability that the first letter selected is M and the second letter is H? So again, we get 4 choices, right? So we have to choose first from 4, then I have to choose from 3, correct? So that would give me 12 different permutations, right? 12 different arrangements on how I can set the word math in how I can write it with the T being first, the H being second, the A being third, and the M being last, for example. But then out of that, there's only one arrangement where M and H can come in first and second. So then it would be 1 out of 12. Okay, 1 out of 12 is about 8%. Okay, I hope that makes sense. And here's our guided practice. Please go ahead, take this time to read through it and make sure that you feel comfortable answering these questions. If you don't, go back to examples 1 or 2, example 3 for number 2, or example 4 and 5 for number 3. Go ahead, read through it. You do not have to do it. We will do it together in class. See you then.